We're going to be doing the 2024 methods exam. I'm going to have the marking key up, so this is going to be a full 100% walkthrough of how to do the exam. And I just want to say good luck to everyone who's about to sit the exam in about, I think, a week plus, depending on when I upload this. And I'll also be working on the specialist exam 2024 as well. And then I was quickly going through and I was like, I was still remembering some of these questions because this was obviously the exam that I sat about, 10 months ago, 11 months ago. But yeah, alright, let's just get started. So we have this first question: differentiate the function f of x is equal to x squared ln 4x plus 3. So we can see here quite clearly we're going to have to use the product rule along with the rules for differentiating ln functions. So if we just put it all together, first differentiating x squared, this should be pretty easy, 2x, and then we just plot this at the end. Differentiate this and then just times it by that. Okay. Now for the other side of the product rule, we're going to do plus. Now differentiating ln functions, remember it's a derivative on top of the inside function, then we just have the inside function on the bottom, plus 3 times x squared. So maybe if we clean this up a bit, x plus 3 plus 4x squared all over that. I think I'm going to make my pen a bit smaller. Okay, moving on. Just double checking this is the correct answer, and yes it is. Moving on. Determine a fully simplified expression for g of x, given that the derivative of g of x is that, and g of 1 is equal to ln of 6. So obviously this is going to be, to get from the derivative to the initial function, we're going to have to do some integration. So we can say g of x is equal to the integral of 3x on 3x squared plus 1, and it's going to be dx. So straight away you should be able to see that this is going to be integrate into an ln function. If we think of the derivative of this is just going to be 6x, and that is very close to what we have at the top there. So if we just get 6x on top of this, if we get 6x here instead of 3x, we'll be able to integrate straight into an ln function. To get that, we have to multiply the top by 2. So if we multiply the top by 2, we have to divide outside by 2. Just like that. Then this will be very easy. This will just give us a half, and this will just be the bottom function plus c. Now since we know that g of 1 is equal to ln of 6, then we can substitute in g of 1 into this function here, see what we get. So you know that ln of 6 is going to be equal to half ln of 3, 4 plus c. Okay, from here we can simplify this expression a bit. Since we have this half out the outside and it's being multiplied to the ln 4, we can put it on inside of the ln of 4 as the power. So we have ln of 6 is equal to ln of 4 to the power of a half. Now when something's to the power of a half, remember we're taking the square root. But then when the square root of 4 is pretty simple, square root of 2 plus c. So then we know that c is going to be equal to ln of 6 minus ln of 2. Then using another log rule, we know that when we're taking away logarithms from each other, we're actually dividing whatever's on the inside. So this is going to be 6 divided by 2, which is going to be ln of 3. Therefore, g of x is equal to half ln of 3x squared plus 1 plus ln of 3. Excellent. Then we can simplify this even further. Since we have this half on the outside, we can square root the inside of this ln function, and then whenever we're adding ln logarithm functions together, then we can multiply them. So maybe I put this up, and we can say g of x is equal to ln, we're going to have 3 on the outside, multiplying by the square root of everything here. Just like that. Okay, if you're a bit confused on how we got that, if you think of it like this, so first we apply the square root to the first ln, Then we have the ln 3 on the outside. then obviously we have to multiply, so we just plop it in front of the square root there. Alrighty, moving on. An advertising graphic motion moves across the bottom of a television screen during a sporting game, changing direction to attract viewer attention. The position of the graphic is modeled by this function. Okay, x is in centimeters, position relative to the left of the screen, and t is in seconds. Position, we have a table down here. Determine the velocity of the graphic when it first appears on the screen. So obviously velocity is, everyone should know, is the derivative of the position, and we're given the position function, so we can maybe write v of t is equal to x dash of t, which is going to be t squared minus 14t, and I forgot the last bit there, plus 40t. So the differentiating that will just give us 40. These are just all power rules, so it's pretty simple. Just multiply the power to the coefficients and then lower the power by 1. Now it wants us to find the velocity when it first appears on the screen. Obviously that's going to be at time 0, so this is going to be 0. Oh wait, sorry, no, not 0. This is going to be 40, and then just including our units, centimeters per second. Okay. Velocity. Oh, the answer actually says specifies to the right of the screen as well, so to the right. I'm not sure if that's a key point though, but sure. Is the graphic initially speeding up or slowing down? Now to determine if it's speeding up or slowing down, we have to find acceleration. And remember, acceleration is again just another derivative, so we have to take the derivative of the velocity. So we can write a of t is equal to v dash of t, which is going to be equal to 2t minus 14. Now remember, initially this is quite obviously meaning a of 0. So a of 0 is just going to be 0 minus 14. And this will again be second per second. So initially it will be slowing down. Okay, to the right. Therefore, initially graphic is slowing down. It's slowing down as acceleration is opposite to the direction of velocity. Okay. Quite obviously no, it's opposite to velocity since we have this negative sign at the front here. Okay, so that means that while initially it's moving 40 centimeters to the right, it is being decelerated to the left here. Okay. Moving on, evaluate this integral and explain what the integral means. Okay. So, oh, I'm in blue now. If we put this into here, t dt, we know that the integral of a velocity is just going to be the position. So this is actually going to give us x of 9 minus x of 3. Now let's see, x of 9 is 36. If you didn't know where I got these numbers from, it's just going to be this. So x, oh wait, that's going to be a bit weird to write. But yeah, pretty much x of t from 9 to 3, like that. And then you just plug in the numbers, substituting. Now minus x of 3 is 66, which means it's negative 30. Okay. Then remembering our units, this means, and since there's no absolute value functions here, this is going to be displacement. So we can explain this as the integral represents the displacement of the graphic from t equals 9, oh sorry, t equals 3 to t equals 9. Calculate the total distance traveled by the graphic from the time it enters the screen to the time it leaves the screen 15 seconds later. Okay, so we know that to find the total distance, if we had a calculator, we could use absolute values. However, since we don't, this is hands-free, we have to find when the graphic starts to change direction. Okay, because for example, if we're just looking at displacement, right, let's say our graphic travels 100 centimeters to the right like that, and then at the very end it travels 30 centimeters back. If we're talking about displacement, then we only consider this 70 centimeter change. However, since it wants a total distance, we have to add up all of these changes together. So actually this is going to be thinking 100 centimeters plus the 30 centimeters. So we have to find whenever the graphic changes direction. What that means is that we have to find when it so if it changes direction, obviously there must be a certain exact point where it is at rest. So to find that, we know that v of t is equal to, I have it here somewhere, t squared minus 14 14t plus 40. So when it's at rest, obviously our velocity is going to be 0. So actually I won't write that, I will just write, let's just write t squared minus 14t plus 40 is equal to 0. Then we have to solve this for t. Now if you're quick, it should be a pretty simple one. You can see that this will factorize like this, t minus 4 with t minus 10. Because this, we can break this up into a negative 4 and negative 10, and that also adds up to our negative 14t there. If not, maybe if you want to use the quadratic formula, but I think that's a bit excessive. Anyway, from here, you can find that the times that our graphic is going to be at rest is t equals 4 and t is 10. So from there, what we can do is that we can take away, so therefore total distance, sorry, not take away but sum, is equal to the time t4 minus t0. Okay, oh sorry, not x, not t but x 0. What this is doing is that we're finding the distance traveled between the initial start to the first time it changes direction. Then we want to add the next time, which will be x of 10 minus x of 4. Okay, maybe we should put brackets like this. So this is the time from t equals 4 to x equals 10, because we know that x equals 10 is going to be the next time it changes direction. And then the final one, which is going to be x 15, because that's when it stops, to x of 10, just like that. Now we just have to plug in these values. X of 4 is 69 and a third, plus minus 0, I think. Yes, minus 0. Then let's bracket that, plus x of 10 is 33 and a third, minus 69 and a third, plus x of 15 is 150 minus the 33 and a third. Okay, so what we can do now, we know that this is going to be 69 and a third plus, and a third, this will be 36, plus this is going to be 126 and 2/3. We're going to sum this all together. Okay, we're going to get 1 from this 1/3 and 2/3. So let's just say this is 70 plus 36 plus 126. That's going to be 106 and 200. Hold on, I think I did something wrong here. Oh yes, this is supposed to be 116. Whoopsies. Okay. So then we're going to have 106 from these two. 106 plus 116 is going to be 222. And just remembering our centimeters. And I believe that's our answer. Yes, 222. Excellent. Okay, moving on. The table below displays the partially completed probability distribution and cumulative distribution for discrete random variable x. So we have drv x. So we just have to complete the table. Now remembering that this cumulative probability means, for example, if we have p of x less than or equal to 2, what we do is that we sum the probability of x being equal to 1 plus p of x equal to 2. So from here we already know it's 0.2 and 0.15, so we know this is going to be 0.35. Okay, pretty much this cumulative probability is all the probabilities below it and also equal to it summed together. So for the cumulative probability for x less than or equal to 3 to be 0.6, this must be 0.25. Okay, because 0.6 is going to be equal to 0.2 plus 0.15 plus, let's call it x. Okay, we know that this is going to be our 0.35, so we minus that. 0.6 minus 0.35 will give us 0.25. And then following the same logic here, for this to be 0.95, this needs to be plus x, well this is x. So 0.95 minus 0.6, this will be 0.35. And then at the very end, but pretty much what we do is we just add these two together and that will give us 1. Okay, moving on to the next question. Evaluate probability of 2 less than or equal to x less than or equal to 4. How we can do this quite simply is that we just have to sum up the individual values that it's asking for. So it wants us to go from 2 all the way to 4. So we can sum up probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x equal to 4. So we have 0.15 plus 0.25 plus 0.35. Summing the first one, we get 0.4 plus the 0.35 at the end, we get 0.75. Very simple. Another way to do it would be to do probability of 2 less than or equal to x less than or equal to 4. This is the probability of x less than or equal to 4. Then you take away everything from the left side that you don't want. So since we want to start from 2, we would start taking away from 1. So the probability of x less than or equal to 1. That kind of makes sense here. Then you should also get the same. So 0.95 minus 0.2 will also give you 0.75. Okay, evaluate probability of x equals to 1 given x is less than or equal to 3. This is also quite simple. We can just use the definition that this is going to be equal to x is equal to 1 and x is less than or equal to 3. However, since x is equal to 1 and x is less than or equal to 3 is always going to be like this kind of what I'm trying to say is that this part is kind of redundant. Okay, so we can actually just do that divided by the probability that x is less than or equal to 3. Now what this shows is that we can just plug in the numbers and then it will give us the value back. So this is going to be 0.2 all over 0.6. Okay, then we can simplify this fraction. We can multiply the numerator and denominator by 10 to give us 2 on 6, which we can simplify to 1 on 3. Okay, moving on. The uniformly distributed continuous random variable has an expected value of 6 and a maximum value of 9. Determine the variance of x. Okay, so since we know this is uniformly distributed, it has an expected value of 6, maximum value of 9, then if we draw a graph here, let's have an expected value of 6 here, okay, and then the maximum value of 9 here. We know that this area is going to be halfway because this is the mean, the 6 is the mean, this is our maximum. Then it should be quite intuitive that since the maximum is 3 away from the mean, then the minimum is also going to be 3 away from the mean, only because we have this uniformly distributed continuous random variable. So this is what we have, okay? So, and since this is continuous, we're going to be using integrals rather than summation. So we can firstly write that f of x is going to be equal to to find our function that this even runs on. Okay, now we're going to have some probability k here. Remember, k is going to be 1 divided by the maximum minus the minimum. Okay, so we can see that this spanned a distance of 6 what do you call it, 6 units, right? So since we know that 6 times k, actually I'll just write 6k equal to 1, 6 is our length, k is going to be our height since this is a rectangle, and the sum of the probabilities must be 1, or the sum of the area must be 1. We know that k is going to be 1 on 6. This means that f of x is equal to 1 on 6. Given that we are within the range, x is less than 3 is less than or equal to x, is less than or equal to 9, and 0 otherwise. Oh, what? Oh yeah, okay. The marking key also says otherwise. Okay, then we can simply plug this into our variance formula. So variance of x is going to be equal to the integral of 3 to 9 of x minus the mean squared times our height, which is going to be our f of x. Now since we know our f of x is already going to be 1 on 6 for this range from 3 to 9, we can just put it outside like that, dx. Okay, then obviously since the 1 on 6 is a constant, we can just pull it to the outside. 9 of x minus 6 to power of 2 dx. Then we just have to compute this formula here. Now, if you guys are wondering why this is the case, this is the formula. Think of it like we are finding the distance x that it is away from the mean here, 6. And then since sometimes we're going to get less, we're going to be to the left of the mean, then if we square it, that's when we get the positive value. Okay, and then we're also going to multiply that by the height of our rectangle here, which is going to be 1 on 6. Okay, so continuing evaluating our integral here, square bracket, we're going to have x minus 6 to the power of 3 all over 3 from 9 to 3. It's going to be 1 on 6 times x minus, okay, it's going to be 9 minus 6 is 3, so 27 divided by 3 is going to be 9, minus 1 on 6 of, it's going to be negative 3, so negative 27, so we're actually going to plus that, and then negative 27 divided by 3, so then this is going to be, I feel like I did this wrong somewhere. Oh no, this is correct. So 1 6. This is going to be 18 on 6, which is going to be 3. But the answer? That is the answer. Excellent. Okay, moving on. The binomially distributed discrete random variable w has a mean of 1/2 and a variance of 5 divided by 12. Evaluate p is equal to 1. Okay, so straight away we can find out using the formulas that were, well, the values that were given, and that knowing that this is binomially distributed, we know that the mean of a binomial distribution is given by np, where n is the number of trials and p is the probability of success, and we are given that this is equal to 1/2. Okay, because remember, binomial distributions are just when you have a Bernoulli distribution repeated over and over, and obviously the mean of a Bernoulli distribution is p, and since we're repeating it over and over, we just multiply it by how many trials we are doing, and that will give us the mean of success. Okay, and then the variance of a binomial distribution is np1 minus p, which is given as 5 on 12. Okay, so now we can figure out our parameters for w, and then from there we can substitute those in and find out what pw equals 1 is. Okay, so since we know that this is 1 on 2, and we have 1 minus p is equal to 5 on 12, then we can multiply this across. We know that 1 minus p is equal to 5 on 6, so then, p is going to be equal to 1 on 6. If p is 1 on 6, then we know that n is going to be 3. Okay, therefore w is a binomial distribution where n is 3 and our probability of success is 1 on 6. Okay, so now we know our parameters. We can just simply plug this in to find out what PW equals 1 is. Wow, I cannot write my 1 properly. So here, since we want PW is equal to 1, we can do 3C1 times the probability of success to the power of how many times you want it, times the probability of failure squared, like that. Now, anything C1 is just going to be the top left number, or how many options there are. Okay, so 3, 1 to the power of 1 divided by 6 to the power of 1 is 1 on 6, times 25 on 36. To simplify this a bit, we can just make that 1 on 2. So we have a half times 25 on 36, which is going to be 25 over 72. And I don't think that can simplify anymore. Checking the answer, 25 on 72. Yep, excellent. Okay. So for this one, we just used the values that they gave us. And then we were able to substitute some things in to find our parameters here. And then from there, we are able to plug those parameters into the formula for finding the probabilities of a binomial distribution. Okay. Remembering that this 3C1 here is the different ways that we are able to get one success. Okay, because since there's 3 trials, we do 3 trials, then you can either get a success on the first one, the second one, or the third one. And we sum all of those up. The function f of x is equal to log a of x is plotted below, where a and p are constants. Express log a of 0.5 in terms of p. Okay. So 0.5 can also be written as 1 on 2. 1 on 2 can also be written as 2 to the negative 1, or log 2 minus, log 1 minus log 2. A of 2. Now these are both ways that you can express this, okay? Then from here, for this one, you would write negative log a of 2. Okay. And then for this one, you can just plug in the values here. But since log a of 1 is 0, as it always is, you're also left here with negative log a of 2. Okay, so then let's do it the faster way, which would just be going straight from here to log a of 2. And then we are given log a of 2 here, which is p, so this would just be negative p. Okay. The 1 minus 2 is that whenever we have a division inside our logarithm function, we can separate it out into into a subtraction. Evaluate a to power of 5p. Okay, so since we have a as our base here, if we have a logarithm for on top with the log a, and those will cancel out, we can get that logarithm as we can see this p here. So let's do, this is going to be equal to a to the power of 5. Now remember, p is equal to log a of 2 here. Okay, so we can do 5 log a of 2. Then what's going to happen is that these logarithms are going to cancel out, but we can't cancel them out yet as we have this 5 in the coefficient. So if we simplify, now we can cancel it out. When these cancel out, we are simply left with 2 to the power of 5, which will give us 32, because 2, 4, 8, 16, 32, yes. Okay. Now we have to solve this logarithm function for x. So the 3p. Now I think on the graph there was the exact value for 3p. 3p is when x is equal to 8. Okay. So we know that log a of 8 is equal to 3p, and then we have log a of x minus 3 is also equal to 3p. Therefore, we know that x minus 3 is equal to 8, so x must be 11. Maybe we can say this one from graph. Okay, the function f of x equal to log a of x has been transformed to give two other logarithm functions with base a on the axes as shown below. Now, base a means that it's the same like initial base function here. Okay, determine an equation for each of the two functions, a and b. Okay, starting off easily with our graph b here. It might take a second, but you should notice that each point is always 1 unit away from, or each horizontal line, or each height value or output is always 1 unit away from the initial function f of x. For example, whenever at p is equal to like 2, 5, 6s here, it's always 1 unit away. For 2p, we're at x equals 3 and then x equals 4. For 0, we're at x equals 0 and x equals 1. Okay, it's always 1 unit away, and it's 1 unit away to the left, meaning that we can write this as, so b, we'll just write it as log a of x. Since we're going to the left, this is going to be plus 1. Okay, now just to make sure this makes sense, let's put x equals 0 here. Then this will be log a of 1, which is also 0 in our initial function. Then for a, also similar, you should see that it's always unit p away, but above now. Okay, so for x equals 2, our initial function is at p, while our function a is at 2p. For x equals 1, our initial function is at 0, but our a function is at p. So this one actually is a little bit easier. This will just be log a of x plus p. However, again, we can use that substitution that we've used quite a few times already, where log a of 1, log a of 2 in our initial function is equal to p. So this is actually going to be x plus, we can write log a of 2. Then again, since we have an addition, we can use our logarithm rules and we can multiply these together. So this we can write as log a of 2x. I believe that's the answer given. Yes, excellent. Okay, a graph of y equals x sine of pi x for 0 to 1 is shown below. In the diagram, show the region whose area is equal to this integral. Okay, so what we do is we just take the bounds here. So we go from 1 on 6 to 1 on 2. And then we just have to shade this region. Very easy, just like that. And since these are our bounds, that's all we have to do. Just shade that region. By considering the areas of the rectangle shown in the graph above, demonstrate and explain why blah 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 is blah blah. Okay, so let's say for the lower bound, this is a type of question that comes up quite often, so it's good to practice this. But pretty much what we want to do is that we want to show that the lower bound, which is going to be the sum of these rectangles here, must be less than the area of this, and then we show the same thing for the upper bound and we combine them together. So lower bound rectangles area is going to be equal to 1 on 2, 1 on 12 times, and then here we have 1 on 6 plus the height of the other one is square root of 3 on 6 times, again, the width of our rectangle here is 1 on 6. Okay, so then this is going to be equal to 1 on 72 plus square root of 3 on 36, which we can simplify to 1 to square root of 3 all over 72. Okay, we just multiply this by 2 on 2, so we get the same denominator. Okay, and then clearly the lower bound, the area of the lower bound rectangles is less than the area given by the integral. Okay. Maybe I should say area given by. And then we show the integral here, 1/6 to 1/2. And then it was x sine pi x dx. Okay. Then we can do the same thing for the upper bound. Honestly, these are like my least favorite questions to do because they're so repetitive. This is going to be equal to square root of 3 on 6 times 1 on 6 plus the other upper bound is 1 on 2 times another 1 on 6. So then this is going to be square root of 3 all on 36 plus 1 on 12, which we can simplify to 3 plus square root of 3 all over 36. And then again, clearly, area of upper bound, maybe I should say this as 1. Area of upper bound rectangles is greater than the area given by this, so 1 on 2, 1 on 6, x sine pi of x dx. And you can see therefore, oh, I didn't write it here either. Therefore, 1 plus 2 square root of 3, 172, less than 1 on 2, 1 on 6, x sine pi of x dx. And then for here, it was going to be 3 plus square root of 3 on 36. It's greater than 1 on 2, 1 on 6, x sine pi of x dx. Okay, then we can label this as point number 2. Combining point 1 and point 2, we have that 1 plus 2 square root of 3, 72, is less than the integral which is again, the integral is less than 3 plus square root of 3 all on 36. Okay. Oh, they call it overestimate and underestimate. My bad. Area of overestimate rectangles. And then this one, upper bound rectangles, lower bound rectangles. So overestimate. And then area of the underestimate. Something like that. If you say lower bound, maybe it'll also be fine, but apparently if you want the marks 100%, in the marking key they say overestimate, underestimate. Okay. Then moving on, state one suggestion on how to approximate B could be improved. Okay. So then we can say using more rectangles of smaller width. There you go. Obviously, as these rectangles get smaller, then the area that they encompass will also be better. We go from there, then let's say if we halve this one, then the area is going to be closer to the integral. Then obviously you guys learn, as the width of those rectangles becomes 0, then that is when you can, then that is the definition of the integral sign there, and dx. A bicycle rolls down a ramp from initial height of 5.15, as shown in the diagram below. The speed s of the bicycle when it reaches end of the ramp is given by that. Determine the speed. The ramp angle is 45 degrees. Okay, so all we have to do is just plug in 45 degrees there. So maybe if you write as sine of 45 is equal to cosine of 45, because I don't want to write it all out too many times, it's just square root of 2 on 2. Then we know that s of 45 degrees is going to be equal to square root of 101, square root of 2 on 2, minus square root of 2 on 2, all over square root of 2 on 2. Okay, so then this is going to be equal to square root of 100, square root of 2 on 2, all over square root of 2 on 2, or the square root of 100, which is going to be 10 meters per second. We're in meters, right? Yes, meters per second. Okay, because these square root of 2's will cancel out. Determine that. Simplify your answer. Okay, how I will do it, since if we try to do it using quotient rule, it's going to get quite messy. But we can just say that this is equal to d theta of, we can have 101, because if we break up these fractions like that, hold on, maybe not like that, but if we break it up like 101 sine of theta all over sine of theta, clearly these sine of thetas would cancel out, and then we can have that sine of theta. Alright, and this will actually become cot of theta, but I don't think I can't remember, I'm pretty sure in methods you guys don't learn cot, pretty sure that's a spec thing, and the derivatives and everything of that. But we'll just do it the long way, just to be safe. So we have cosine of theta divided by sine of theta, and then this will be much easier for to calculate the derivative of. So then this is obviously the derivative of a constant is 0 minus, okay, then we have derivative of the top, which is going to be negative sine of theta times derivative of the top, and then it's sine of theta here, minus derivative of the bottom, which is cosine of theta, times cosine of theta. Quotient rule, I nearly forgot it. Then we divide that by the bottom squared. So then all of these negatives will cancel out, that they will become a plus here. So then we have sine squared plus cosine squared of theta all over sine squared of theta. And obviously the top is the Pythagorean identity, so that's just 1. So we have 1 sine squared of theta. Oh, the marking key did the full thing. That's kind of disgusting. But okay, I mean, this is also a valid way, so it should work out fine. What I mean by the full thing is, from here they did like 101 cosine of theta plus sine of theta times sine of theta minus cosine of theta times 101 sine of theta. Oh my god, I have no idea why you would do this. Theta, and then these would cancel out, and then you're left with just this times that and this times that, which will also give you sine of theta, sine squared of theta plus cosine squared of theta. Yeah, it'll give you the same thing. It's just a bit of a longer route. But no problem, we still got the same answer. Hence, show that ds d theta is equal to that. Okay. So, oh yeah, s was our speed formula. Okay, so then ds d theta, what we can do is that since we know that s is all of this, right? We can actually put that in a bracket, and we can put that as 1 on 2, because obviously the square root is just whenever you have the exponent of a half. Okay, so then we can use our chain rule. So then ds d theta is going to be equal to 1 on 2 times all of the s stuff to the negative a half. Remember, we take away 1, put it to the outside. So if I do this, so it's going to be it's going to be 101 sine of theta minus cosine of theta all on sine of theta to the negative half times, because we have to use our chain rule here, and we already know that from b, the derivative of the inside is going to be 1 on sine squared of theta. So then we can simplify this here. So we're going to have 1 on 2 sine squared of theta, and then this we're going to have the square root of the inverse of the inside. So it's going to be sine of theta all over 101 sine of theta minus cosine of theta. Okay, very nice. Now, if you guys, this is kind of like a little trick where you can just straight away go to the inverse of the square root. Okay, but otherwise, if you want to do it properly, it would be 1 over 101 sine of theta minus cosine of theta all on sine of theta. Okay. Then from here, you can multiply it by Then from here, since this is quite ugly right now, because we have it on the inverse, we can multiply it by square root of sine of theta over square root of sine of theta. Right, then this square root of sine of theta will cancel with that. So then we are left with square root of sine of theta on the top, with the square root of 101 sine of theta minus cosine of theta. And then whenever you have square roots on top and the bottom, square root of a divided by square root of b is just equal to square root of a on b, which is why we can just put the square root over the whole thing there. Then I'm pretty sure, let me check the answer. Yes, that is the correct answer that we're looking for. Okay, then from here, use the increments formula to estimate the change in s if the ramp angle is changed from 45 to 46 degrees. Okay, so we know that some small change in s, small change in theta is roughly equal to ds d theta. So this is going to be roughly equal to ds d theta with some small change in theta. Okay, so first we need to find out ds d theta. Ds d theta. Hold on, I'll write at theta equals 45 degrees. Theta equals 45 degrees, where 45 degrees is the same as pi on 4. Okay, so then at this, we have that ds d theta is going to be equal to, ds d theta is all of that, 1 on 2 is going to be square root of 2 on 2 squared times. Now what you might notice is that this is actually just the inverse of our s function here, and we already found what the s function was when it's at 45 degrees, or pi on 4, which is 10. But this is actually just going to be 1 on 10. Now what we have to do here is to plug in these values. So 2, that's going to be 2 on 4. 2 times 2 is just going to be 4, so this is actually 1 on 1. So this is actually just 1 on 10. Then we know that s of that is equal to 1 degree, or pi on 180 radians. Since we're working in radians here, we better work in radians when we talk about increment. Also, an increment of 1 degree, remember, small increments, this formula only works when the increments are very small. If you have an increment of 1, then it doesn't really, it's not really approximately equal. So when we have pi on 180, obviously pi on 180 is much smaller than 1, so it works out better. So what we have here is that the small change in speed is roughly equal to 1 on 10 times pi on 180, or quite simply pi on 1800, and our units were meters per second. And that is the end of calculator 3. Alrighty, so that was how a quick run through of how to get 100% on calculator 3. Apologies if my explanations were a bit here and there. I mean, it's been 10 months since I've done methods, and I just quickly went through the marking key just to make sure that what I was doing was correct. And yeah, honestly, some bits were some bits since it's been so long, lost the intuition a bit, so I've had to stop and think about how to explain things, and it's probably not come out properly out of my mouth, but hopefully at least you guys can see them working out. You can see how the thought process is there, how to get to these answers. Alright, and then once I scroll through the rest, we will go and do calculator assumed now. Alright, see ya. Okay, so now we're moving on to the calculator assumed section. So make sure obviously you have your cast everything, and then let's just get started. So John is given a prescription for blood pressure tablets by his doctor. Each tablet contains 5 milligrams of the active medication. The mass of the active medication A remaining in John's body, TL, is given by this formula, where A is in milligrams. Calculate the mass of medication remaining in John's body 10 hours after taking a single tablet. So then all we need to do is just find A of 10, which is going to be 5e to the negative 0.173 times 10. Then in CAS, this is going to be equal to 5e negative 0.0173 times 10, which is 4.21 milligrams. Okay, so this question, next question is half that. How many hours would the mass of medication remaining in John's body have halved? Okay, we know that at t equals 0, this is going to be 0. Remember, e to the 0 is just a 1. So the starting, we're only going to have 5 milligrams, whatever. Right, a 0 equal 5. So then we know that we want 2.5 left over. The 2.5 will be 5e negative 0.0173t. And we can just solve this on CAS. Negative 0.0173t. So then we can write CAS here. T equals. And then let's find out. So solve 2.5 equals 5e e negative 0.0173x, which will give us 40.07 hours. So we can say roughly about 40 hours. Alright, or 40.1 if you want to do 3, that doesn't really matter. The next question, determine at what rate the mass of medication remaining in John's body is decreasing 24 hours after taking a single tablet. So here, since we're talking about an instantaneous rate, we want to find the derivative. So we can find a of t is going to be equal to negative. Remember, when we have when we're differentiating exponential functions, all we do is that we take this coefficient here and we put it as the coefficient for the e, since this is derivative. Okay, so we're gonna have negative 0.0173 times 5. Then we're gonna have e negative 0.0173t, since that stays the same. Then this is 0.06. Sorry, no, 0.865, I think. Negative 0.0173t. Let's see if I'm right. 5 times 0.0173. Yep, okay. Then all we have to do is plug this into our calculator for 24 hours. So obviously that's going to be 0.0865 e negative 0.0173 times 24. Then just plug this in our calculator. Negative 0.0173 times 24. Then we get negative 0.057. This is going to be milligrams per hour. Then we can finalize our solution because it's asking for decreasing rate. So then, since we have a negative here, this is clearly going to be decreasing. So we say decreasing at 0.057 milligrams per hour. Alright. Next question. If a tablet is taken every T hours, the mass of medication B remaining in John's body immediately after taking a tablet will be given by this formula, where B is also in milligrams. How frequently should John take a tablet so that the mass of medication remaining in his body immediately after taking each tablet is 8.85? So what we want to do is just set that equal to this, E negative 0.0173T. If we multiply this denominator here on the bottom to the left, where did my pen go? There we go, undo. 85 minus 8.85 E. Oh, sorry, let's hold on. So we will multiply this across and then divide by that just to make it easier, and then we will minus the 1. Actually, I'll pass it over. Okay, we'll do that. So we'll do E. Okay, let's just do it step by step. 1 minus E negative 0.0173T is equal to 5 divided by 8.85. Then I'll move the E to the right and my whatever this fraction to the left. Then we will ln everything here. So we'll do ln of this we can simplify to 3.85, sorry, all over 8.85 is equal to negative 0.0173T. And we can just do T is equal to negative ln of 3.85. Actually, on a CAS it will be easier like this. Over 8.85 divided by negative 0.0173. Then putting this all in the calculator, we get 48.11 hours. Okay, then but honestly, I think if you just did this in your CAS, the very first step, it will also give you the same thing. Let me see, 1 minus E, because honestly this feels like quite a lot of work for 2 marks. So yeah, it does give the same answer if you just go the solve from the very first step. Using the increments formula to approximate the change in B if the time taken between tablets increased by 30 minutes from the time determined in part D. Okay, so I think roughly maybe they oh yeah, in the marking key they said roughly 48 hours. Okay, so then we want that D, what do they call it, dB over dt is roughly equal to a small change in B divided by a small change in T. So we want SdB to be dB dt times SdSt. Okay, so first we have to find dB dt. So dB over dt is equal to, it's going to be quotient, so derivative of the top is 0 minus derivative of the bottom. Derivative of the bottom is going to be, so minus, that's going to be 0, negative, so the negatives will cancel out, 0.173 E negative 0.0173T, and then we're going to multiply this by 5, so it's going to be 865. Okay, so it's going to be negative 0.0865. Wait, was there another 0? Yes, there is another 0.0865 to negative 0.0173t all over 1 minus the bottom squared. Then we know you can also just use your CAS, I guess, to find that out. So at t equals 48, we have that this is all equal to dBdt is equal to negative 0.118, and then it was milligrams per hour. Now if we did 48.11, would our answer be much different? Also 0.118. Okay, then we have that S of B is equal to a half hour, since it's 30 minutes. So then we have the S of T, or small change in T. Our small change in B is going to be equal to negative 0.118 times a half, which is going to be equal to negative 0.059 milligrams per hour. And that is going to be our small change in B. Alright, next up. A mathematics teacher uses a coin flip activity to determine the confidence interval to their class. Or to demonstrate confidence interval, to flip a fair coin 50 times and observe 30 heads and 20 tails. Calculate a 90% confidence interval for the proportion of heads obtained when the coin is flipped. Okay, so the sample, the proportion from this sample is going to be 30 divided by 50, which is 3 on 5, or 0.6. Okay, then for our confidence interval of 90%, we need to know that we need to know the standard deviation first. So sigma is going to be equal to 0.6. 1 minus 0.6 is 0.4, and our sample size was 50 equals. So this is 0.6 times 0.4 divided by 50. 0.069. Then our K value is going to be 1.645. Am I right? Yes, I'm right. Okay. I was looking at the marking key there. Therefore, our margin of error is going to be equal to 1.645, 0.069. I think this is the correct way. I remember doing this a different way. This doesn't feel like the same way I would have done it, but it's whatever. 0.113503. 505, I mean. Therefore, 90% confidence interval. Yes, 90% confidence interval is going to be 3 on 5 minus 0.113505 less than 3 on 5 less than 3 on 5 plus 0.1135 on 3, which is going to be equal to 0.4865 less than. Oh wait, no, they just did it. Oh, because this one here they didn't use here. Okay, I guess that is more accurate. Okay, apologies. So they just went straight from here. Maybe we can do that. That was 50, just to be easier. So 1.645, because I was like, the number I got is not the same as the answer key. D plus 3.5. But the process is the same, so I assume if I showed the working out like that, it would also be fine. It was like the 4th decimal place was a little bit off, but that's just because obviously I had to round for the standard deviation here. So if I do that, then we get this is equal to 0.4860 less than 0.6, which is and the upper bound is 0.7140. Alrighty, state the distribution for x, which is the next step. I'm going to ask all 20 students calculate their own 90% confidence interval. Let x be the random variable that denotes the number of students whose confidence interval contains the true proportion of heads. Okay, so if we have a 90% confidence interval, obviously that means that roughly 90% of the intervals of the 90% confidence intervals are going to contain the true proportion of heads. So, and since you either contain it or don't, this is going to be repeated Bernoulli trials for all 20 students, aka a binomial trial. So we can say that x is a binomial trial where we have 20 and the success rate is 0.9. Determine the expected value and variance of x. Okay, just like in our calculator 3, expected value is just going to be NP, which is 20 times 0.9, so that'll be 18. And then variance of x is, maybe I should write here, E of x, so equal to that. Then variance of x, let's make it a bit nicer. This is not very nice. Okay, 18. And variance of x is going to be NP 1 minus p, which is going to be 18 times 1 minus 0.9, which is going to be 0.1. So 1.8. Okay, correct. Calculate the probability that the confidence intervals of 3 students do not contain the true proportion. Okay, so all we require is that x is the binomial distribution of 20 and 0.9. Then from here on CAS, what to show is that binomial just 3 students. So we're going to use a probability density function of, we have total of 20 students. We want them okay. So we want probability of x is equal to 17, which is going to be equal to binomial. Well, actually, we could do 20C17. This is so much work. How did they do it? Okay, they just anyhow did it in the marking key. Okay, but I liked the binomial PDF ones. Maybe that is what lost me a lot of marks in my exam. Binomial PDF, if I remember correctly, is the total. Then we want 17, and our success rate was 0.9. Let's see if that gets us. So on my CAS, I'm going on the top left action, distribution / INV. Then since this is discrete, we select discrete, then we have binomial PDF. So 20, 17, 0.9. That is not how that works. Yeah, I had to swap these two numbers around. So 17 and 20. Then this gives us 0.1901. If you're not confident in doing that, maybe honestly that might be where I lost my marks, because I just showed it on a CAS. Then instead what we can do is probability of x is equal to 17. 20C17 times 0.9 to the power of 17, 0.1 to the power of 3. Remember, this is our binomial distribution. Okay, so we have total 20 trials. We want 17 successes. Probability of success is 0.9. So we put that to the power of 17, and the rest we assume is failures, which is 0.1 to the power of 3. So if I go keyboard, I forgot where, I think it's in advanced, yes, NCR 2017, 0.9 to the power of 17 times 0.1 to the power of 3. It also gives us the same, so 0.1901. Question 10. A book called Why I Love Mathematics, excellent, is having its first print run. This is scheduled to last for 1 week, using 4 printing presses. The publisher claimed that historically 10 books have printing errors for every 200 that are printed. A sample of 200 books is to be chosen to determine how many contain errors. The proposed sampling procedure is to select the first 200 books printed over a 6-hour window using the newest printing press. Okay, what I can see here is that we're choosing the first 100 books. Another error could be that we're only using the newest printing press. Okay, so only choosing the first 200 books. And this is ignoring any this is like ignoring any other books that are printed, because this is going for a full week. Okay, so this ignores errors that occur later in the week due to like things like wear and tear or fatigue of the machine. Tear or fatigue of machinery, or new operators, or new printing press operators. Okay, this is the performance might change. Performance affecting performance as the week goes on. So this, I'm pretty much just taking this straight from the marking key here. These may affect performance. Throughout the week. Okay, the other one is you're only choosing the newest printing press, or since it only says to identify one, but I'll go through the next one. So if you only are choosing the newest printing press, the newest printing press likely has less defects, is more, what's the word? It will perform at a higher, what am I trying to say? The newer printing press, since it's new, likely comes with less defects, is more likely to perform at a higher level than other older printing presses, which will obviously affect the rate of errors that in the printing. So newer printing press likely will perform better than the other three older presses. And then this means it's going to produce less errors while printing. I don't know what's up with my pen right now. Less, I already wrote less, right? Produce less errors in printing. Identify 2 changes to the sampling procedure that would reduce bias. So pretty much we just do the opposite of it. So we can sample books from all four presses, and then we can also take it throughout the duration of the whole week. So sample books from the whole week. Whole duration of the full week. Okay, moving on to the next question. Use approximate normality of the distribution of sample proportions to determine the probability that the sample proportion of books with errors is less than 0.04. Okay, so obviously normality, so we're going to have a normal distribution. For normal distribution, we want to find the mean first. So we can say U is equal to, now here the sample proportion, and we can just use the publisher's claims because we have like no other data. 10 books for every 200 that are printed. So the mean is going to be 10 on 200 or 0.05. Then next would be our standard deviation, which is going to be 0.05 times 0.95 all on 200. And then our variance will just be that square. That should be a nice number. It is 0.0002375. So we can say let our sample proportions approximate a normal distribution where we have 0.05 and 0.0002375. So then we want the probability of the sample proportions being less than 0.04. Okay, so then we want probability of that being less than 0.04 is going to be equal to binomial. Oh, sorry, not binomial, norm CDF. Well, binomial, that came out of nowhere. Normal's cumulative density function. We want to go from 0, because obviously we can't have a negative sample proportion, to 0.04 of our mean, which is 0.05. Wait, is it mean first? It might not be mean first. Is it? Yes. Okay. Standard deviation first. So standard deviation is just going to be square root 0.05, 0.95, all over 200. And then our mean is 0.05. So putting this into a calculator, going to action, distribution, inverse, continuous, normal CDF, 0.04, square root 0.05 times 0.95 divided by 200, comma, oops, I clicked all the way. Where am I now? And then, okay, 0.05. We get that this probability is 0.2576. In a different random sample of 600 books, it is found that the proportion of books containing an error is 0.1 with a margin of error of 0.025. Determine 95% confidence interval for the proportion of books that will have printing errors. Okay, so all we have to do is for 95% confidence interval, we have that k is equal to 1.96. I'm pretty sure, I can't remember, but we'll see in a second. Therefore, margin of error is going to be, oh wait, they already gave us the margin of error, never mind. The margin of error, wait a minute, it's found a proportion from margin of error. Honestly, I think this is a bit of bad wording in a different random sample. So they give us the margin of error here, but it didn't say that it's for the 95% confidence interval. But I'm just looking at the answer sheet right now. All it does is it just take the 0.1 minus plus or minus 0.025. Okay, so maybe wonder what I did during the exam. But yeah, it's just going to be 0.1 minus 0.024 less than 0.1 is less than 0.1 plus 0.024. So then this is 0.076 less than 0.1 less than 0.124. Okay. Next up, okay, sure, 4 decimal places. 0. Forgot, does the middle one need 4 decimal places? Oh, I'm rusty, guys. 0.1240. Alright, so that's our confidence interval. On the basis of the confidence interval, part C, what is the proportion of books with printing errors different from what was claimed by the publisher? So the publisher claimed 0.5. So publisher claimed a 0.05 sample proportion this falls outside the 95% confidence interval in C. Therefore, uh, 95% confident that oh, it's just asking if it's different than what it's going to be. Alright, 90% confident that publisher is incorrect in his sample proportion. Now the marking key is a bit different here. It says this proportion is not within the confidence interval, so there is sufficient evidence to conclude that the claim of the publisher is incorrect at the 95% confidence interval. Okay, yeah, same thing actually. Suggests two changes that could be made in order to decrease the margin of error of the confidence interval. So remembering that margin of error is equal to k square root of p1 minus p on n. Okay, we can either decrease confidence level. When we decrease the confidence level, we are able to kind of contain more values of the sample proportions, so our k will increase. Or we can increase sample space, increase sample size. Because as we increase sample size, n will increase, so then our margin of error. Oh wait, hold on, sorry. To decrease the margin of error. Oh yes, decrease, and this will be increase. So we increase confidence level. As we increase confidence level, then we contain less and less sample proportions, so our k will decrease. And if we increase sample size, then our n is going to get bigger. It's going to be dividing by a bigger number. Okay, so since our margin of error is k square root of p1 minus p divided by n, the very first thing we can see here, if we want to decrease the margin of error, is to increase sample size, which is n. As we increase n, obviously that's going to be dividing by a bigger number in our square root, so everything's going to decrease. Now we can also decrease our margin of error if we decrease our k. To decrease our k, we need to have we need to decrease our confidence level. Okay, because as we decrease our confidence level, then we are not containing as many sample proportions, so our k decreases. Determine the minimum sample size that will be necessary to guarantee the margin of error resulting 95% confidence interval is at most 0.02. Key here is guarantee. So we have that 0.02 margin of error. Yeah, okay, margin of error. 95% confidence interval is correspondent with k value of 1.645 square root. Now to guarantee that this will be the minimum sample size, we need to use the p hat is equal to 0.5, since that maximizes the margin of error. Then we just do divided by n. So if you want to solve this slowly, we can, but I think it's fine if we just put solve in the CAS again. So then for CAS, let's see, 0.02 is equal to 1.645 times square root 0.5 squared divided by x. Oh, 95% confidence interval is 1.96. There we go. So then here we have, oh, it's straight on to, it's a exact number. So we have n is equal to 2401. And all right, cool. Yes, that is the answer. Okay. A protest group looking to abolish the circulation of physical money, noting coins, claims that 74% of Perth residents have not used physical money in the past 12 months. To investigate this claim, a data scientist surveys a random sample of Perth residents, with 70% claiming they have not used physical money in the past 12 months. Let P denote the proportion of Perth residents who have not used physical money in the past 12 months. Given that the width of the 95% confidence interval is 0.096, determine the 95% confidence interval for P. Okay, so that the whole width of the confidence interval, so we know our margin of error is going to be half of that. So 0.048, therefore 95% confidence interval is going to be 0.7, because that was the actual, that was the actual sample. 0.048 less than 0.7, should be a colon, and this will be 0.7 plus 0.048. So this is going to be 0.6520 less than 0.7 less than 0.7480. Okay, determine the number of people surveyed. So if our margin of error is 0.048, this must be 1.96 square root of 0.7 times 0.3 times n. So then on CAS, we just want to solve. And this will give me 0.48 is equal to 1.96 times square root 0.7 times 0.3 divided by x. I get 350, n is equal to 50.1. So then we can say roughly, we can say 350 people surveyed. What does the data scientist confidence interval suggest about the protest group's claim? So 0.054, protest group's claim. Sample proportion of 0.74 is within the data scientist 95% confidence interval. For 95% confident that protest group correct. Protest group are correct. Okay, now I'm just looking at the answer marking key. They how do I put this? They word it as the claim cannot be rejected at the 95% confidence level. Okay, so claim cannot be rejected at the 95% confidence interval, confidence level. Alright, moving on. The data scientist interested in whether the proportion is similar to that in other Australian capital cities and conducts surveys in Brisbane, Sydney and Hobart. The following information was recorded based on the survey results for each of the following city pairs, identifying which had the widest 95% confidence interval. Justify your answer. Brisbane and Sydney. So they have the same sample proportion. same thing, but if we want to have the wider confidence interval, then the smaller sample size is going to win. But Brisbane's sample size less than Sydney's sample size. Therefore, Brisbane. And then obviously, to explain why, we have margin of error is going to be equal to K, and then P1 minus P all over N. So clearly, if Brisbane sample size is smaller, or Sydney sample size is bigger, it's probably easier to explain, then we're going to be dividing by the bigger number, our margin of error is going to decrease, our confidence interval is going to be narrower. Okay, Brisbane and Hobart. So Brisbane and Hobart have the same sample size, so same sample size, but Brisbane is closer. Brisbane's sample proportion is equal to 0.65, which is closer to the maximum, which is closer to 0.5 than Hobart's 0.75. If closer, so since it is closer, we'll have larger margin of error, therefore larger 95% confidence interval. Maybe I should say that here as well. So therefore larger MOE for Brisbane. Therefore larger 95% confidence interval for Brisbane. Alright, next page. Question 12. A log of a circular cross-section is being prepared for milling. The log is to be cut into 5 usable pieces, one large beam with a square cross-section and 4 sideboards as shown in the diagram below. Determine the exact radius of the log. Okay, so it's a square cross-section, so we know that all these angles are 90 degrees. That's very good because then we can use some bit of Pythagoras. Okay, if this side is 40 here, then we know that this side must also be 40, and then we must know that this diagonal is 2 of the radii. Okay, so we can do some easy Pythagoras. So we can say that 2r squared is going to be equal to 40 squared plus 40 squared. So we have 4r squared is going to be equal to 2 times 1600, which is going to be 3200. Divide that by 4, we get 800, square root that. Then we get 10 square root of 8, which is going to be 2 square root of 2, so I think 20 square root of 2 times 400, yeah, just like that. Okay, and then obviously put in our units there. Using the variables defined in the diagram, show that the cross-sectional area in centimeters squared of a single sideboard is that. Okay, so we know that this is right. So area of sideboard is equal to y times x. We know that our area of the sideboard is is equal to yx. What we have to do is find a substitution for y. Now the substitution we can use is that here we know that this is half of y, so y on 2. We know that this length here is going to be half of the square, which is 20 plus x. And we know that the radius here is 20 square root of 2. What this means is that, we also have the 90-degree angle, so we can plug this all into our Pythagoras, oh my god, I can't speak. We can plug this all into Pythagoras' theorem. Okay? So we have 20 square root of 2 squared is going to be equal to y squared of 2, or y squared of 4 plus 20 plus x squared. So okay, so here if we square the 20 square root of 2, we're going to have 400 times 2, that's going to be 800. We're going to leave our y squared on 4 plus, expanding this, 20 squared is 400, x squared is just x squared. Then we want to double 20 times x, which is 40x. Okay, now let's do some quick simplification. 800 minus 400, oh god, 800 minus 400 is 400. Then we want to multiply that by 4, everything by 4. To get rid of this, divide by 4. So we can say that 1600, because 400 times 4 is 1600, so equal to y squared plus 160x plus x squared. Now let's move the 160 and x squared over to the left. Oh, it's supposed to be 4x squared. And then we'll be left with y squared is going to be equal to 1600 minus 160x minus 4x squared. So then y, it will be equal to plus or minus 1600 minus 160x minus 4x squared. And here we can simplify a little bit more. As we can see, everything is divisible by 4. So then we can pull that out of the square root. Square root of 4 is 2. 1600 divided by 4 is 400. 160 divided by 4 is 40. 4 divided by 4 is 1. So we're left with this. But then as y greater than 0, only take the positive, and so 40x minus x squared. And here it's quite simple. We can see that the area of sideboard which we'll say as a of x is equal to yx, which is going to be 2x square root 400 minus 40x minus x squared, which is what we needed to show. Alright, now we have to use some calculus and determine the dimensions x and y that maximize the cross-sectional area of one sideboard. Okay, so then we can just find the derivative, which is going to be product rule, some chain rule. Oh god. Okay, so first we'll just do 2 square root 400 minus 40x minus x squared. Then we can do plus. Okay, let's just start off easy with the 2x here. If we do our chain rule, this is going to be minus 2x minus 40. Then we have the negative 1 on 2 square root of everything here, which is 400 minus 40x minus x squared. Okay, so this 2x is simply, because I split it up like that. Okay, so we just go straight down there. Then the derivative of this, since this is just 400 minus 40x minus x squared to the power of 1 on 2, we can bring the power to the coefficient and then minus 1. So then we are left with 1 on 2, 400 minus 40x minus x squared to the power of negative 1 on 2. Then we have to multiply that by the derivative of the inside function, which is just negative 2x minus 40. this negative 1 on 2 coefficient means, first of all, we are going to have 1 on 400 minus 40x minus x squared, and then the 1 on 2 will mean we square root that. And I hope you guys can see that this matches up with what I've written here. Let's delete all of this. Okay, so then now we can simplify this even more. Okay, so first of all, since I see we have this on the bottom and this on top, if we multiply this portion by this, by pretty much the whatever's in the third on the top and the bottom of a fraction, you can see that the top is going to become a square, so we will just be left with whatever is inside the third, just like that. Maybe put some brackets around it, and then we'll be dividing by the third itself. Okay, then for this we can simplify as well. So the negative ones will cancel out all of this, and then the 2's will cancel out. So the 2's will cancel, these will become pluses. So then what we're going to be left with is 2x squared plus 40x, all on the third. So if I just go to the back like this, minus. Okay, then we are left with the third here on the bottom, so 400 minus 40x minus x squared. Then from here, you can simplify it all the way down. Oh yes, this should not have the negative in front of it here. Okay, there we go. So then this should actually be negative everything on the inside. Yeah, let's do plus, negative, negative. Okay, so then now we can simplify. So then here we have 800 minus 80x minus 2x squared minus 2x squared minus 40x. Okay, then everything will be over the same denominator. Then we can just collect like terms. So we have 800 minus 2x squared, or 4x squared minus 120x over this. Okay, now we know that we need the derivative of this to be 0. Then what we're going to have is negative 4x squared minus 120x plus 800 is going to be equal to 0. So we divide everything by negative 4. We have x squared plus 30x minus 200 is going to be equal to 0. And I don't think there's any, you can factorize this anyway. Okay, so I think this is just going to go on the CAS. So then CAS, we're just going to do solve of this. So solve of x squared plus 30x minus 200 is equal to 0. Give me some standard. Minus 200. Okay, so this is going to be negative 15 plus or minus 5 square root of 17. But then as x must be greater than 0, we must ignore the negative, so it must be x minus 15 plus 5 square root of 17. Clearly the other one, since the negative 15 minus 5 square root of 17, that's clearly going to be less than 0. Okay, then let's just check at x equals negative 15.01 plus 5 square root of 17. we have a dash of x is equal to. So we can put this in onto my calculator, given that x is equal to 15 plus 5 square root of 17. We have that this is going to be a of x is greater than 0. Wait, hold on, maybe I should write the full thing in here. Then a of negative 14.99 plus 5 square root of 17. So right now I'm just doing the sign test on either side, and this is less than 0. Okay, so what this is showing is that right before the point at negative 15, so let's say we have this point negative 15, we are increasing. So we're going up, 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 and then after negative 15 plus 5 square root of 17, whatever, we're going down, 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 down. So clearly this is our maximum. Therefore, a of at x equals negative 15 plus 5 square root of 17, a of x, not a dash of x, a of x is at a minimum, or as at a maximum turning point. Therefore, y is equal to this. So let's just put this in the calculator. 400 or square root of 400 minus 40x minus x squared, given that x is equal to 15 or negative 15 plus 5 square root of 17. Okay. Therefore, y is equal to 23.99 centimeters. X equals, what is this as a decimal number? 5.62 centimeters will give maximized cross-sectional area. Wait, hold on. Not a of x. Will maximize cross-sectional area of one sideboard. Of one sideboard. Alright, moving on. Question 13. Brianna is considering buying an electric vehicle from Zapper Motors. The manufacturer claims that on average, a driver will be able to travel 350 kilometers before needing to recharge the vehicle, and the probability of traveling more than 400 kilometers needing to recharge is 0.2525. That's the distance in kilometers that whatever motor vehicle will travel before needing recharge. Assume x is normally distributed, random variable. Determine the standard deviation of x. Okay, so we know that the probability of this is 0.2525. So let's have z equal a normal distribution of 0, 1 squared. Okay, so what we're going to do is we're going to find the corresponding z value for a probability to be 0.2525. Okay, so then on my CAS, what I'm going to do is go to action in distributions, continue inverse, and then there's an inverse normal CDF. Okay, I'm gonna put my tail setting to the right because we have the probability of traveling more than 400 kilometers, 0.2525. So then I put my probability as 0.2525, my standard deviation is 1, and my population as 0. So we know that this z score, z greater than 0.2525, z greater than k, sorry, what am I doing? Oh, that z is equal to 0. No. z greater than k is equal to 0.2525. Cas inverse norm CDF gives k being equal to 0.6666. Okay, now since this is the z value, we know that this is going to be equal to 400 minus 350 all over the standard deviation. Alright, so then from here we can just find that standard deviation is going to be 400 minus 350 divided by 0.6666. So the standard deviation is 75. Alright. There's a few more decimal places, but I assume it's just because I didn't use the exact value for the standard deviation. Brianna will need to travel regularly to Albany, which is 420 kilometers away from our house. Calculate the probability that on any given day she is able to drive to Albany without recharging the vehicle. So let's see. We have let x be a normal distribution. Now we know the mean, which is going to be 350 from the information given. Then our standard deviation is 75. Therefore, we want the probability that x is greater than or equal to 420 is equal to norm CDF of 420 to infinity with our standard deviation of 75 and our mean of 350. So again, action, distribution, continuous, norm CDF, and I'm just going to copy down what I wrote. And this gives us 0.1753, which is the probability given. Alright. Matthew is interested in buying the same type of electric vehicle, but he lives in England. But as he lives in England, he would like to consider the distance in miles. Okay, let y be a random variable that denotes the distance in miles. Let 0 travel before needing to recharge. Okay, so we can say that y is equal to 1 on 1.6x. Therefore, the expected value of y is equal to 1 on 1.6 times 350, which is going to be 218.75 miles. And then the variance of y is just going to be 1 on 1.6 squared times the variance, which is going to be 75 squared of our x. So 1 divided by 1.6 squared times 75 squared. It's going to be 2,197 miles squared. Is that correct? Yes. Alright, awesome. Okay, moving on. Brandon decide. I think this would be the last. Wait, no. Oh, wait, no. What am I talking about? There's way more questions. Oh, yes, I remember this one. Oh, I'm excited now. Okay, because electric vehicle from the rival company Spooky Cars. I show her histogram below. Based on 200 trials of his electric vehicle. We read the notes of distance in kilometers that Spooky Car traveled before needing to recharge. On the basis of the diagram, is it appropriate to use a normal distribution to model the distance traveled between recharges? Justify your answer. No. The graph is not symmetric because obviously there is a skew to the left here. So, no. Graph is not symmetric. Around the mean point. Okay, assuming the distances are uniformly disformed within each interval, use the histogram to estimate the expected distance that a Spooky Car will be able to travel before needing to recharge. Oh my god. There's no way. Was this an exam? Man, I think I must be kicking myself if this was an exam. Okay. What? This is ridiculous. Okay, so we have to use the midpoint of every, I assume, yeah, unit distributed within each interval. So, okay, let's do this. The midpoint of this is going to be 270, 290. Okay, so 270 times. Now it said there were 200, right? Okay. So then this is going to be times 4 on 200 plus 290 on, I think it was going to be 8 on 400 plus 310 on 10 on 200 plus, oh my god, 330 on 12. Wow, this is very boring. Plus, whoa, a door just slammed. 350 on 18 on 200 370 40 390. What's that? 54 410 32 34 plus 430, which is at 20. Okay, then all of this added up. Oh my god. Man, this is so easy to make a mistake, I can imagine. Alright, 200 plus 350 times 18 divided by 200, 370, 40, 390, 54, 410, 200 plus 430 times 20 divided by 200. And then we get 375.8. Alright, just like that. In which company's vehicle would Bernard be more likely to drive to Albany without recharging? Justify your answer. 10. So require wait, hold on, let's just do P of W greater than 420. Now 420 will be 20 on 200 or equal to 0.1. Then probability of do we use Z before? X. Probably X greater than 420 is 1753. And therefore, is that true? Okay. As its probability of driving more, the required 420 kilometers or more is greater than keys. All right. Okay. Next question. Mathematics teacher Mr. Ulam provides a new game. He uses standard dice, 4 of them. Rolls the dice, any dice of 1 facing up, a winning dice, and then a remove. Okay, the remaining dice are rolled again. Game is finished when a player has 2 or more winning dice. Game 500 times, quote how many rolls it takes to win a game. Let X be a random frequency results. Displayed below using experimental data above. Estimate the probability of winning in exactly 2 rolls. Okay, well then this here, this is 5 roll 3 2 1. And probability of winning is just going to be equal to 113 on 500, which is going to be 0.2260. Okay, let me double check. Yeah, okay. Not winning in 2 or less rows. The probability of that is equal to probability of is equal to 1 minus the probability of winning in 2 or less. Which is going to be equal to 1 minus 66 on 500 minus 113 on 500. Because not winning, okay, if we look at just winning in 2 or less rows, obviously it's this section, but then it's asking for not, so we just do 1 minus all of that. So then this is going to be 179, so 321 on 500, or 0.6420. Say 2 reasons why the game cannot be modeled using a binomial distribution. Okay, remember binomial distribution, one factor is that it must be the same trial every single, or same number of trials every single time. However, in this, the trials are not the same every time. It is instead, the number of Bernoulli trials that you're doing is changing between each game. Because for example, you might win in the first round straight away, but then sometimes it takes all the way up to, what is that, like 14 rounds to win the game. Number one is that the probabilities must stay independent of each other. So the trial that you're currently doing should not be influenced by the trial before it, and it should not influence the trial after it. However, in this case, clearly this is not the case, because we are removing dice if they are winners, and obviously that will influence further trials. So pretty much the probability of success is not fixed. Okay, so let's do the probability of success. Success changes. For example, if a dice is removed, and then number 2, the number of trials is not fixed. So remember, for a Bernoulli trial, we need 2 parameters. We need the number of trials, and we need the probability of success. So obviously, if this is always changing, then our binomial distribution is always going to be changing, and if our probability of success is also changing, then it cannot be modeled using a binomial distribution. And then also we have the third point where the trials are not independent of each other. Okay. You can just add a number 3 here. We only need 2 though, but trials are not independent. So for example, even if we had the same number of trials every single time, let's say we had 5 trials, but then the first trial has p equals 0.5, but then second trial has p equals 0.4, there's no way to express this in a binomial distribution, since we only have the second parameter is the probability of success, and that assumes it for all the trials. So if the trial is always changing, then obviously it cannot be a binomial distribution. So these two are closely linked, but not necessarily the same thing. Okay, most of them is computer simulate 10,000 games. So the probability of each outcome. Simulation games so much better. If the game is won in 1 or 2 rows, the player wins $2. If the game is won in 3 rows, the player wins 1. If the game is won in 4 or more, the player wins nothing. And the profit for a player who wins a $1 game. Or distribution for Y. Okay, so the player can either lose $1, can make 0, or they can make $1. They lose the dollar if game is won in 4 or more rolls. So we have to sum up all of these, but I think it's easier if we do the other way. So if in 1 or 2 rolls, then they win $2. So what we have to do is just sum up these two, which is going to be 0.349. 3 rolls to player, so 0.208. And then the negative one is just going to be minus all of those. So 1 minus 0.208 minus 0.349, which is 0.443. Alright, maybe we can write here y equal negative 1 is equal to 1 minus 0.208 minus 0.349. Okay, expected value of y. We have to multiply all of these together, so negative 0.443 was it? Plus 0 times 0.08 plus 1 times 0.349. So then this will all equal, so negative 0.443 plus 0.349, expected loss of $0.094. Now the variance of y is just going to be the difference from each of these to the mean, which is our expected value here, times the probability. So we're going to have negative 1 minus 0.09. Actually, wait. This is going to be plus, because we're going to have minus 0.094 squared times 0.0443 plus 0 plus 0.094 squared times 0.208 plus 1 plus 0.094 squared times 0.349. So putting this in a calculator, we get, this is going to be $sign 0.7832 dollars squared. That's a bit weird, but yeah. Not only do you expect anything to be profit for charity, justify answer. So since the player is losing money, that obviously means that the charity is going to be winning that money. Yes, that's the expected. Profit is negative $0.094 for the player per game, indicating expected profit per game is just the negative of that. Profit charted, yeah. Earthquake magnitude can be measured using the moment magnitude scale, MW, which is our y-axis here, which is related to the seismic moment, M0, of the earthquake. The seismic moment has units of Newton meters. The graph of MW versus log 10 of M0 is given below. Using the graph of appropriate moment magnitude MW of a seismic moment of 3.16. Okay, so we need to do log 10 of this is equal to, just do this in our CAS, so log 10, or log base 10, 6 times 10 to the power of 13 is about 13.5. Therefore, if we go to 13.5 here, because this would be 13, 13.5, then we find the y value associated with that. You can see that this is pretty much dead on 3. Therefore, MW is equal to 3. Okay, aspect grid, oh wait, no, that meant the relationship between MW and M0 can be expressed in the form of this, determine the values of A and B. So pretty much you can think of this as a y equals mx plus c, where our m is just the log 10 of m0. Oh sorry, our x is just the log 10 of m0. So A is equal to the gradient. Come on, save. Gradient, which is equal to, let's see, we go from 9 to, what's the nice even number, 12 here, so that's 3 across, and we go up by 2. So A is going to be 2 on 3, and then our value when log 10 m0 is 0 is going to be negative 6, so that is going to be our vertical, our y-intercept, so B is equal to negative 6. Also figure it out as 2 on 3 times 9 plus B is equal to 0. This is going to be 6 plus B equals 0, or B equals negative 6. And so I've always expressed the relationship between MW and M0 in the form of this. Okay, so we know that MW is equal to 2 on 3 log 10 of M0 plus or minus 6. Okay, so then from here we can do 2 on 3 log 10 of m0 minus. Now, since clearly this is a division on the inside, we're likely going to have a different subtraction of the two logarithms. So for now, we can change this 6 into log base 10, 10 to the power of 6. Because remember, we can put the 6 outside its coefficient, and obviously log 10 of 10 is just going to be 1. However, we can't do the subtraction yet, as we need this 2 on 3 coefficient on the outside of this logarithm. So, how are we going to do that? Minus. So what we want, remember, is the 2 on 3 coefficient on the outside. So, how we can get a coefficient on the outside is putting it as the power on the inside, like that. Because then, like this, we're effectively putting that 2 on 3 coefficient on the outside. However, to keep this the same as that, as the log 10 of 10 to the 6, we need to do the inverse. This will clearly cancel out to 1. So it's just 6 times 1. Alright, so then here we have 2 on 3 log 10 of m0 minus the 2 on 3 log 10 of 10 to the 6 times 3 on 2. 6 times 3 is 18, divided by 2 is 9. So now we can simplify this logarithm into 2 on 3 log 10 of m0 over 10 to the 9. Just like that. Or we could also do it as 9 is equal to log 10 of m0, right? Because we can see here, when this is 9, obviously we're going to have some certain m0 there. And also interesting is that it equal to 0, right? So if we have this, then clearly m0 is equal to 10 to the 9. However, clearly at m0 over c, at this point, log 10 of m0 equal to 9, mw is equal to 0. Therefore, we must have that m0 over c must be equal to 1. So m0 is equal to c, or c is equal to 10 to the 9, with our a remaining as that 2 on 3. Right, another way we can do this is from here you can expand this or pull this outside. We can write log 10 of m0 minus, then here we can do the 2 on 3. So if we pull out 2 on 3, we have to multiply this negative 6 by 3 on 2, which again is just our 9. So this is pretty much the same thing as before. Then we can make this 9 using the same idea here. So we can change this to log 10 of 10 on 9. And it's the same thing. So here we have the subtraction of logarithms. So we have m0 over 10 to the 9. Alright. Determine the seismic moment m0 of an earthquake of moment magnitude mw equals 4. So we have 4 is equal to 2 on 3 log 10 of m0 on 10 to the 9. This is going to be 6 is equal to log 10 of m0 10 to the 9. So then from here we can do 10 to the power 6 is equal to m0 10 to the 9, right? Because we just make everything the exponent with a base of 10. Then here these logarithms and the exponent will cancel out. So then just multiplying this one across, 10 to the 15 is equal to m0 is ab times ac is just equal to ab plus c. So all we're doing here is we're adding this 6 and this 9 together to get the 15. Okay, and then obviously just remembering our units. So 10 to the 15 Newton meters. Here we go, the shampoo bottle question. It's partially filled with a uniform parabolic cross-section as shown in the diagram below. Both x and y are measured in centimeters. The width of the bottle is perpendicular to the parabolic cross-section. It's perpendicular to the parabolic cross-section. is 4 centimeters. Calculate the volume of shampoo in the bottle. It is partially filled to a height of 10 centimeters. Okay, so here what we need to do is we need to find this point here where y is equal to 10, because it's partially filled up to 10. So we can do 10 is equal to, because from here, okay, what I'm thinking to do is we will find the area of this rectangle, okay, whatever this k will be. Then we will just find from k all the way to 5, we will integrate this formula here. Okay, so we have 10 is equal to 20 minus 4 on 5 x squared. So then we're gonna have a negative 10, but there's a negative here, so this will just be 10 is equal to 4 on 5 x squared. 50 divided by 4, it's gonna be, okay, 25 on 2 is equal to x squared. So So then we'll say x is equal to plus or minus 5 on square root of 2. Alright. So we have it here and here. So this is 5 square root of 2. And this here is also 5 on square root of 2. Okay, so then we know that therefore area, let's label this as area A, and we'll label this one as area B. Is equal to 2 of 5 square root of 2 times 10. Oops, saving PDF. So there's going to be 100 on square root of 2. Then we know that area B is just going to be the integral from 5 on square root of 2 to 5 of 20 minus 5 on 4 squared dx. Okay, so then this is 5 square root of 2. Oh wait, hold on, we don't need integral anymore. This is just going to be 20x minus, so we raise the power and divide by it, so 5 on 12, x to the 3, 5 to 5 on square root of 2. Now this is, oh wait, I forgot this, we can use calculator for this. Okay, let's see what we get on the CAS pad. Let's do the integral. 5 divided by square root of 2 and 5 of 20 minus 5 divided by 4 squared dx. Does it need the exact? It does not look like it needs the exact. Okay. Why is this giving me negative though? Why is this giving me a negative? Let's see, 5x squared on 4. Oh, 4. On 5x squared. So then this would be 4 on 15. Oopsies. Okay, so that's giving me 7.741 centimeters squared. So then total volume is going to be 2 of area B, 1 plus the area A, so 100 on square root of 2 times 4. So 2 times 7.741 plus 100 divided by square root of 2. Then we want to multiply this all by 4. So we get about 344. 7 centimeters cubed. Alright. We multiply B because obviously we have this symmetric side on the other side too. Okay. The bottle is turned upside down and the entire volume is allowed to settle as shown in the diagram. Determine the shampoo level H. So we know that the area must be roughly, so area is equal to, maybe we say total shaded area, 344.77 divided by 4. Maybe not divided, we'll just do divided by 4 like that. So we should get about 86.19 centimeters squared. Okay. So then we need to find the height that this is. So we know that the integral of the h minus 4 on 5x squared dx, and we also need to find the bounds that this occurs at. So okay, let's find the bounds first. Bounds at h is equal to 4 on 5x squared. So then to find x, it's just going to be square root plus or minus square root of 5 on 2 square root of h. Okay, so then those are our bounds. Therefore 86.19 is going to be equal to negative square root of 5h on 2 square root of 5h on 2, where we have h minus 4 on 5x squared dx. Then we can just plug this into a calculator. So then solve all of that. So 86.19 negative square root of 5h on 2 h here is our height. Wait a minute, is it just minus that? Yes, because h will give us that rectangle. Then the integral of the 4 divided by 5x squared will give us this, and this as well. Will give us that area, which will leave us with the remaining area that we want. So h minus 4 on 5x squared dx. And then on CAS, we have h is going to be equal to, let's see if we even get an answer. Instead of h though, we'll just use y. So square root of 5y divided by 2 negative 5y squared root divided by 2 of y minus 4 on 5x squared dx. But then I want y. Okay, then I get that y is equal to 14.95 centimeters, which is the answer. Nice. Okay. Another way you could have done it is taking half of the area. So let's say that it's going to be a bit rough actually, since we used a rounded figure. But if you did it with the exact volume, seems like the exact volume was 1600 minus 400 square root of 213. This is going to be equal to 4 times 2 of, again, the bounds. So but this time, since it's symmetric, we will just be looking at this half, so there, and then it will be square root of 5h on 2, and then again h minus 4 on 5x squared dx. Alright, okay, then from here we can do 200, we can just divide everything by this 8. So we have minus 50 square root of 2 all on 3. It's going to be hx minus increase the power by 1, divide by it, x power 3. And we have the square root of 5h on 2 and 0. Clearly, if we put 0 into these x's, our bottom lower bound is just going to be 0. But here we have h square root of 5h on 2 minus 4 on 15 times 5h square root of 5h, since we have the to the power of 3 here, so we can break that into 2 plus 1, so then we can square this and have another 5h there. then this is going to be all over 8. Okay, so then from here we have 200 minus 50 square root 2 on 3 going to be equal to 5 square root of 5h to the 3 on 2 minus, if we cancel these out, that's just going to be 1/2 and then a 3 on top, a 3 on the bottom. So we have square root of 5h to the 3. So then 1/2 and 3, that should be equal to 6. 1/2 and a third. Okay, so then if we multiply everything by 6, 400 minus 100 square root of 2 equals, because to get this to 6, we multiply this by 2, so we put 2 everything on the top. Same thing to get everything on the bottom here by 6, we need to multiply by 3, so we just put 3 as a coefficient there. Minus square root of 5h to the 3. So then that's just going to be 2 square root of 5h to the 3. So then I'm just going to divide everything by 2. So 200 minus 50 square root of 2 is equal to root of 5. Straight like that. Then squaring this, we have 40000 minus multiply these two together, 1, so 20,000 square root of 2 plus 2,500 times 2, so 500 is equal to 5h to the 3. Then dividing everything by 5, we have 8,000 minus 4,000 square root of 2 of 100. So actually this would just be 100 here. 5h to the 3. Oh, sorry, just h to the 3. So then h is just equal. Oh, okay, here should be 5,000. So then this should be 9,000. Then here everything's still 1,000. So then we cube root the 1,000 and we keep the 9 on the inside, it'll be 10. And here, h is equal to 9,000 minus 4,000 square root of 2. To a third, which will give us 14.95. Nice. Okay, but obviously I like my way better. But yeah, honestly, you could just do the same thing. You could just do the solve here from the CAS. Okay. Last question. Speed cubers are people who try to solve Rubik's Cube as quickly as possible using pre-learned algorithm sequence of turns to potential result in faster turns. 493 algorithms assume that they modeled by equation. T is since the learning commenced, and B and C are constant parameters. So if they already know 21 at t equals 0, t equals 0. 21 is equal to b log 4 of 1 plus c. So then c is going to be 21. Because this is log 4 of 1 will just become 0. B times 0 is 0. So we're just left with c. An additional 32 algorithms by the end of the first week. So then at t equals 1. Additional 32. So we're going to have 53. is equal to b log 4 of 2 plus 21, so 32 is equal to b log 4 of 2. Okay, here then log 4 of 2 is just equal to a half. Since we need that 4 to the power of some c is going to equal 2, we know that the square root of 4 is 2, so c will just be a half. So then this is 32 is equal to b on 2, so b is equal to 64. Right, determine how many of the 0 will learn after 26 weeks. So at t equals 26, a of 26 is going to equal 64. Log 4 of 27 plus 21. Let's put down a calculator. Probably learned 173.16. Therefore, approximately 173 algorithms. Based on the assumed model, with the speed to learn the entire ZBLO algorithm set within a lifetime. So then we require the time in weeks. So and that was 493. Log 4 of t plus 1. Oh wait. Oh yeah, okay. Plus 21 cas. And we're just gonna do solve all of this on my cas. T is equal to x plus 1 plus 21. 27553.5 weeks, which is equal to about 530 years. So therefore no, as it much goes past expected human life. Let me just check that this is correct. Yeah, 528 years. Alright, so that is the end of the calculator assumed. I think there's nothing else much to do. Alright, then it will be good luck to everyone taking that 2025 exam. Goodbye.